Hey everybody, this is your pre-cal video on circles. It's the second one. So basically you're given that the radius is 1/5, so you do r squared is 1/5 squared, which is the same as saying 1 squared over 5 squared. And so that's how you get that part. And then based on this, you do x minus the 1/5. And you never put y minus 0 for a final answer. Just keep it y squared. Now, that part was pretty straightforward, but then on this part, you got to go from here to there. So what you do is you have x minus 1/5 squared plus y squared equal 1/25, and you got to do FOIL. So x times x is x squared. Then we need minus 2 times the product of this, which is 1/5 x, and then plus that squared would be 1/25. And then we have plus y squared equal 1/25. Let's go ahead and subtract your 1/25, and they both go away. And then this is x squared minus 2/5 x plus y squared now equals 0. So sometimes you're going to see it like this. Sometimes you may see it like this. It could be either way. I guess on the example paper, they wanted it with the y squared and x squared in front. But yeah, those are technically equivalent. Then they just want you to graph it. And if it's 1/5 comma 0, that means you went right 1/5. And so that's going to be this one. Now on this one, they want you to find the center and graph it and so forth. This is where it may be useful if you use the calculator, so let's try that. So remember I talked about equation templates in the other one, in the other video. So if we go to graph entry to equation templates of a circle, this bottom one, which is number 2, is standard form, and we would put 1 in here, and it filled in the 1 there. Then we've got a -4 in front of the x, a -6 here. Now here's, whoops, what happened there? It should have been the same. Okay. I need to type my -4 in front of my x. And I need to type my -6 in front of the y. And I need to type a -3. Okay, so there it is, which is like what they have. Now, when you analyze conics, okay, so let me go to graph, entry, edit. First, let's mention 3 equation templates. And then type your numbers in. It was 1, 1, -4, -6, -3. Now you can also go to analyze conics. So remember what we're doing when we're thinking or trying to work a problem. It's called analyze graph. So you can go to menu, 6 is analyze graph. That's where you would normally do your minimums, maximums, zeros, intersections. But then there's also number 8, which is analyze conics. And it has a new menu. Some of these things will not make sense for a circle, like foci, vertices, directrix, some of those asymptotes. What would make sense is the center and the radius. And so if you do center, it pops up as 2, 3. So you'd go to circle and then do center, and it was 2, 3. Now if we go back to that, if we do radius, you see the little line there? That's telling you how far it is. And then you can drop it. You don't have to make it to the side. I was just trying to illustrate it. So there's 4. So that's what I would recommend doing. Now, excuse me, for these intercepts, you're going to have to get an exact answer, not just like estimate it, like, oh, it's negative 2/3 or whatever. So you might end up in doing some of this work like we did in the notes. Okay, so first set it up like that. And then for your first step, you want to do this, divide by 2, and then square it. Well, by doing that, it's really x squared minus 4x plus 4, which is really x minus 2 squared. Now, you can't just randomly add this 4 without putting a plus 4 over here. Now, for the other part, you've got negative 6 over 2 and square it. So that would be like y squared minus 6y plus 9. So that's y minus 3 squared. And again, you can't just randomly have 9 here. You have to do 9 here. And so then this adds up to 7 and 9, which is 16. And so then you can say r is the square root of 16, which is 4. So that's how you do it by hand if you do not know your calculator. Now, for your intercepts, what you're going to want to do is take your equation equals 16. And for the x-intercepts, we think it's a number, comma, 0. So set y equal to 0. So what we do in that case is we have x minus 2 squared plus 0 minus 3 squared is positive 9. And then this is x minus 2 squared equals 7. So what I did was I subtracted 9 from both sides. And now take the square root of both sides. So you have x minus 2 equal positive and negative square root of 7. And then we add 2 to both sides. So we get 2 plus or minus square root of 7. So that tells us it's 2 plus and minus square root of 7 comma 0. Now, that's what they have for the first two answers. They put 2 minus and 2 plus. Now, set x equals 0 for the y-int. So go back to this and you say negative 2 squared is really 4. 4 plus y minus 3 squared equals 16. Subtract 4 from both sides. Y minus 3 squared is 12. And so you get y minus 3 equal plus and minus the square root of 12. So you get 3 plus or minus the square root of 12. Now, the square root of 12 can be broken down into the square root of 4 times square root of 3. So that's really 3 plus or minus 2 square root of 3. And since we were setting x equal to 0, then you do 0 comma that. That's your answer. So these are your y-ints, these are your x-ints. Make sure you take your time on that as you're going through it, and make sure you ask questions if you need to. But in general, you will get square root answers. You can't just fake it or whatever. I mean, you can go to this, but it's not that useful. You can go to analyze graph and then zero the graph. First it's saying which graph. Well, this graph. No, it's this graph. Well, it's being difficult right now, even as it is. But if I had my second one as like just saying 0, and I did the intersection like we normally do, 6 and then 4, this is kind of being difficult. I was trying to show you that even if you got a decimal from like using trace, that it's not that useful. Here it says -1 with something barely above 0. So trace isn't really helping. You could make it match, but that's very difficult to do. Okay, let's move on. Okay. Now this one, again, you can go through the calculator, or since we need to get the intercepts anyway, I'm just going to work it by hand. Well, you know, the first step on this one is you notice everything is divisible by 4. So divide all terms by 4. You might have to do divide by 2 or something else, but if I divide everything by 4, we got x squared, y squared, 6x, 4y, and 12. So now let's group the terms together. So we've got x squared minus 6x, and we have y squared plus 4y, and equal 12. So I'm basically putting my x's together, my y's together, and moving my 12. Now we have to do what we did earlier, like that number divide by 2 and square it. That means you're doing x squared minus 6x plus 9, which means it's x minus 3 squared. And you can tell right off the bat, you know, that you're there. And then 4 over 2 squared. So that's like y squared plus 4y plus 4, which is like y plus 2 squared. So you always take that term, the linear term, divide by 2. Now, like we said before, you can't just randomly add 9 to one side without adding it here. And same thing with the 4. So what's kind of nice about this one is it adds up to 25. So you say r is the square root of 25, which is 5. So that's your answer. Now we need to get our intercepts. So let's set y equals 0 for the accent. So that's going to be x minus 3 squared plus 2 squared equal 25. Notice I'm literally just ignoring the y because it's 0. So we have x minus 3 squared plus 4 equal 25. Then we want to subtract 4 from both sides. So we get 21. Now we do positive and negative square root of 21 and just stick a 3 in front. So 3 plus or minus square root of 21, 0. And so that's these. Those are your accents. Now for your y-ents, you may get lucky like this and just see it. If you can't just see it like that, then set your x equals 0 for your y-ent. So try from the graph. Or do this. So in this case, we'd have 0 minus 3 squared plus 2 squared equal 25. 9. Oh, I didn't use my variable. I meant to put y plus 2 squared. So 9 plus y plus 2 squared equal 25. Subtract 9 from both sides. So you get y plus 2 squared equals 16. Now you take your square root of 16, and that's 4. So positive and negative 4. And then you do negative 2 to both sides. So you'd say 4 minus 2 and negative 4 minus 2. So that's 0 and negative 6. So that's how come you get 0 there. That's how come you get 0, 2 and 0, negative 6. So those are your y-ents. Now, for this one, the easy part is based on the center. Now, on the tangent part, so first let's talk about what tangent means. Tangent means touches one point. So let's say we're at negative 5, 9. And if we say touches the y-axis, then that means from here to here. That distance is 5. And so that meant your radius is 5. So in your formula you use r squared, so 5 squared, which is 25. So that would be a circle that looks like this. It doesn't necessarily go all the way down. In fact, it doesn't. This is just tangent to the y-axis. Now, if you had a different one that was tangent to the x-axis, what do you think you do? You count from here down. And so then you'd say radius equal 9. And then draw your circle. So then that'd be x plus 5 squared plus y minus 9 squared equal 81. So that's if it's tangent to the x-axis. You never know with Math Excel how they're going to change it, if they're going to change the numbers or the words or whatever. So just read the problem carefully. Now this one, your endpoints of the diameter there, so the first thing I would do is get your midpoint. So you do 9 minus 3 over 2, which is 6 halves, which is 3. You do 4 plus 2 over 2, 6 halves, which is 3. So based on that, you have your x minus 3 squared plus y minus 3 squared. So you're basically at 3, 3. Now, we don't really know our diameter. We know we got our midpoint, which is the center of the circle. The center is the midpoint. We don't know our radius or our diameter. So for your diameter, that's going to use that formula with the square root. Remember, that's x2 minus x1 squared plus y2 minus y1 squared. So that's negative 3 minus 9 squared and 2 minus 4 squared. So if we work this out, that'd be negative 12 squared, which is really 144. You'd have negative 2 squared, which is really 4. And then just finish it off. So this is the square root of 148. So that's your diameter. So D equal square root of 148. So your radius would be square root of 148 over 2. Now, the problem with that is you've got to reduce that. That doesn't look that easy to reduce. So I would say on your calculator, do F1 as 148 over X and try to find out something that looks easy to work with. So remember, you can do this when you're working. 148 over X. Now, what does it mean? It means what numbers you multiply together to get 148. And you want to look for things that are perfect squares. So like 4 is square root of, well, 4 is 37. That means square root of 4 times square root of 37 is the square root of 148. That's actually what we need. Now, if we went to 9, we've got 16.4 repeat, which is 16 4/9. If we go to 16, we get 9.25. So none of these others are working, and 25 won't work either. That's 5.92. So we have to use this one, which is the largest perfect square. 4 is the largest perfect square in this particular problem. And so what we do is we say square root of 148 over 2 is really square root of 4 square root of 37 over 2. And then just depending on how much work you want to show, this would be 2 square root of 37 over 2, which is square root of 37. So that's what r is. So that means r squared would be 37. So that's what we put right there. So on our next one, you're given a graph. You figure out, what your center is, and that's 1, -2. So based on that, you go x minus 1 squared and y plus 2 squared. Now for the other part, you need to get your radius. Well, we can't count diagonally, that's not a thing, but you can count vertically or horizontally for your radius. And it's basically 2 up and 2 down. So r is 2, so then we do 2 squared, which is 4. So that's how you do that. On this one, the numbers are a little smaller, but you can do it here and then to about right there. So this center is at -2, 5. Remember, you can zoom in. That's the advantage of doing this on the computer. So that means it's x plus 2 squared and y minus 5 squared. And then you can also count down. And so this would be 5 units. So r is 5. So then we say r squared would be 25 if r is 5. Then for our last one, this is an application type problem, meaning like a word problem with it. It's not that many words. It wants the area of the square inside the circle. So we know area of the circle is pi r squared. We know area of a square is side squared. Well, what can we learn from this one? Well, r squared is 16, which means r is 4. And that's the radius. It's not the thing to the box, it's to where the box and the circle go. So there's your 4. So if your radius is 4, then your diameter is 2 times 4, which is 8. Now the diameter is not really the same thing as your side length. It's longer because of, geometry, because of the right angle. But we could do some math, and we could say side length S of a triangle, S squared plus another s squared equal 8. So 2s squared is 8, because we're just adding like terms. So this is from the Pythagorean theorem. Now you divide by 2, so you get s squared is 4. Oh, I don't know why I did. That should just be 4. Okay, so this should be 8 squared, which is really 64. And then 64 divided by 2 is 32. And you're done. So that was actually easier than I made it, because I needed to do 8 squared. And then you just divide by 2. And there you go. Hope that helps. Have a good day.